Okay, so now let's talk about trig identities. Trigonometric identities. Okay, so for this part, the most important thing is this triangle. So theta is here. This triangle based on the unit circle. Okay, based on the unit circle. So if the hypotenuse is 1, then the adjacent side is cosine, and then the opposite is sine of the angle theta. Okay, so here cosine is the adjacent side and sine is the opposite side of the angle theta. Okay, of the angle theta. Okay, so now from this triangle, first we can get what is tangent theta. Tangent is opposite over adjacent. So we get this is sine theta over cosine theta. Cotangent is you flip that, so adjacent over opposite. So we got cosine theta over sine theta. Okay, sine theta. And then we already know cosecant is 1 over sine, and the secant theta is 1 over cosine theta. Okay, so now for all these properties, we can use these properties to change 6 trig values to only sine and cosine. So every time you have tangent, you change to sine over cosine. You have cotangent, change to sine or cosine over sine. Cosecant, change to 1 over sine. And secant, you change it to 1 over cosine. Then we reduce 6 trig functions to 2 trig functions. So it will be much easier to verify the identity. Okay? To verify the identity. And then the most important property is the Pythagorean theorem for this triangle. Okay, for this triangle. The Pythagorean theorem for this triangle. So we have hypotenuse is 1 squared, and then we have the bottom square cosine squared plus the opposite square sine squared. So simplify that a little bit. 1 squared is 1, so we just get cosine squared plus sine squared is 1. Okay, is 1. So for some harder questions, we need Pythagorean theorem to verify the identity. Okay, to verify the identity. So the key for this whole part is this triangle. Okay, this triangle gives you the relation between sine and cosine and the other 4 trig functions and this special Pythagorean theorem. Okay, Pythagorean theorem. Okay, so now let's look at our first example. Okay, first example. So verify the identity secant theta times cotangent theta is cosecant theta. Okay, cosecant theta. So we want to show left hand side. So this is the left hand side of the equation. Secant times tangent is the right hand side cosecant. Okay, cosecant. So solution or proof. Okay, solution or proof. Okay, so we have to change both sides. We change them, and then if we get the same result, then they are the same. Okay, then they are the same. So left hand side. So we need to change secant times cotangent to sine and cosine function. Okay, so what is secant? Secant is, so let's change the color. Secant is 1 over cosine theta. Okay, and then cotangent is cosine over sine theta. Okay, so now cosine cancelled. We got left hand side is 1 over sine theta. Okay, 1 over sine theta. So similarly, this is right hand side, sorry. We change right hand side also to sine and cosine. So right hand side is cosecant theta. So what's the relation of cosecant and the sine cosine? It's 1 over sine theta. So now you see left hand side is equal to the right hand side. Done. Okay, that. So that's the main idea. So how can we verify the identities? Change to sine and cosine. Okay, change to sine and cosine. So that's the main idea. Change to sine theta and cosine theta. Okay, yeah. So next example. Number 2. So we want to verify 1 plus sine theta over cosine theta is secant theta plus tangent theta. Okay, tangent theta. So first step, the beginning step, change to sine and cosine, both sides. Okay. So now this is the left hand side, that's the right hand side. Okay, right hand side. So now first left hand side. Okay, left hand side. So left hand side is 1 plus sine theta over cosine theta. There's no other trig functions, so we don't need to change that. Okay, we don't need to change that. And then let's look at the right hand side. Right hand side is secant plus tangent. So what is secant? Secant is 1 over cosine. What is tangent? Is sine theta over cosine theta. And then they have the same denominator cosine, so we can put them together. So it's 1 plus sine theta over cosine theta. So now you see left hand side and right hand side are the same. So we got the identity. Okay, we got the identity. So for easier questions, that's the only thing you need to do. You just change everything to sine and cosine, combine something, cancel something, you got the answer. Okay, you got the answer. So now let's look at a harder example. Okay, let's look at a harder example. So let's verify this identity. So this is sine theta times tangent theta plus cosine theta is secant theta. Okay, is secant theta. So still step 1, we need to change everybody to sine cosine. Okay, so now let's look at left hand side first. Left hand side we have sine theta times tangent theta, so this is left hand side. Okay, plus cosine theta. So now what is tangent? So tangent is sine over cosine theta plus cosine theta, right? So we changed tangent to sine over cosine. Okay, sine over cosine. So now we got sine theta squared over cosine theta plus cosine theta. Okay, so there's a small remark for trig functions. So we put the second power between the function and the angle. Okay, so sine squared theta is sine theta squared. Okay, is sine theta squared. I'm going to change this notation. Sine squared theta over cosine theta plus, so that's the definition. Okay, that's the where we put the powers. Okay, it's between the trig function and the angle theta plus cosine theta. So now when you want to add them, you have to get the same denominator. Okay, so that's why we multiplied by cosine and cosine to get the denominator cosine theta for the second part. Okay, for the second part. Then we got sine theta squared over cosine theta plus cosine theta squared over cosine theta. Okay, cosine theta. So now we got cosine theta, sine theta squared plus cosine theta squared. So what's sine theta squared plus cosine theta squared? Remember our identity, the trig identity? This is 1, this is cosine theta, this is sine theta. So the Pythagorean theorem, this is number 1. Okay, this is number 1. So left hand side is 1 over cosine theta. Okay, cosine theta. So now what's the right hand side? The right hand side is secant theta, so which is 1 over cosine theta. You change it to sine and cosine. Okay, sine and cosine. So now you'll see left hand side is equal to the right hand side. we got the identity. Okay, we got the identity. So for harder questions, we need this Pythagorean theorem. Okay, we need the Pythagorean theorem to verify identity. So let's put the Pythagorean theorem up there. So sine squared theta plus cosine squared theta is 1. Okay, it's 1. Because 1 is the hypotenuse here. Okay, 1 is the hypotenuse here. Okay, so let's look at one more example. Okay, so this is problem 4. So let's verify cosine squared theta minus sine squared theta is 1 minus 2 sine squared theta. Okay, sine squared theta. Okay, so now for this question, we don't need to change trig functions to sine and cosine because they are only sine and cosine. Okay, then the only thing we know is this triangle and the Pythagorean identity. Okay, identity. Okay, so now let's first simplify something. So they both have sine squared, so plus sine squared plus sine squared. So we got cosine squared. Right, so let's start again because we didn't follow the left hand side, right hand side, right? Sorry. Yeah, so let's look at the right hand side here. Okay, the right hand side here. The solution. Okay, yeah. So the right hand side, left hand side we cannot change it. Okay, so right hand side there's a number 1 here. That's the thing we want to change. 1 minus 2 sine squared theta. Okay, sine squared theta. So now let's write down the Pythagorean theorem. Cosine squared theta plus sine squared theta is 1. Okay, it's 1. That's the Pythagorean theorem. So there are a lot of squares here. So you should think about the Pythagorean theorem here. And there's a number 1 here. So this is the number 1 that we're going to change to cosine squared plus sine squared. Okay? Yeah. So right hand side is cosine squared plus sine squared minus 2 sine squared. So now this is cosine squared plus sine squared minus 2 sine squared. So put them together, we got cosine theta squared minus sine theta squared. So now this is exactly the left hand side of the identity. Okay, verify this identity. Okay, so left hand side is equal to the right hand side now. Okay, it's equal to the right hand side now. So that's the identity. Okay, that's the identity. Okay, so now we have two things you need to remember to verify the identity. So first you change everything to sine and cosine, and then if there's a second power, consider the trig identities, the Pythagorean identities. Cosine squared plus sine squared is 1. Okay, it's 1. So now let's go back to the beginning slide. Let's explain these things again. Okay, so the most important thing is this triangle. You have to remember this triangle. So this triangle, use the definition of tangent, cotangent. You get tangent is opposite over adjacent, so sine over cosine. Cotangent, you got cosine over sine. And this is the reciprocal identity that we already know. Okay, we already know. And this is the second step. Okay, so that part is the first part. You change all the trig functions to sine and cosine. And then try to simplify whatever you can. Combine like terms, cancel factors, and then in the end, if you need, use this for the second power. Okay, use this for the second power. Okay, so that's it. That's our lecture for the trig identities. So this part is not easy. It's very hard. You have to practice a lot. Okay, practice a lot. But the basic questions are easy. Basic questions, you only need this. You don't need Pythagorean theorem, no second powers. Then you prove the identity. Get left hand side is equal to right hand side. That's how to prove the identity. Okay, simplify both sides until you get exactly the same expression. Okay, same expression.